For the finale of the series, I went after the hardest target, MonkeyOCR, one of the most capable document parsers of 2026. But MonkeyOCR isn't a single model. It's a three-stage pipeline. First, a structure stage detects the layout, then a recognition stage reads each block with a vision model, then a relation stage figures out the reading order. That decomposition is what lets it handle messy, multi-column, table-heavy documents. The question for this series is simple. Can I run it on an 8 gig laptop? And the honest answer has two halves. Here's the document, a sample vendor invoice. This matters for MonkeyOCR because the full system is a three-stage pipeline. Detect the layout, read each block, then order it. Here I'm running only the middle stage, the recognition model, on the whole page. So this is a fair look at the reader on its own, fed the same invoice every other model in the series sees. And here's the code. MonkeyOCR's recognition model is, under the hood, a Qwen 2.5 VL-based 1.9 billion parameter model. You load it from the local recognition folder in bfloat 16 with low CPU mem usage, build a chat message pairing the image with a simple prompt. Output the text content, and call generate. That's the reader in isolation, without the structure and relation stages that normally wrap around it. And this is the real output. The recognition model will read the invoice, the company, the bill to, the line items, and the totals with 232142 correct. But notice it's fairly flat because I ran the reader alone without the structure stage that would have grouped the table. That's the honest point of this topic. The recognition model fits and reads well on 8 gigs, but MonkeyOCR's real strength is the full pipeline around it. Start with the win because it's real. MonkeyOCR's recognition stage, the model that actually reads text, is under the hood a Qwen 2.5 VL based 1.9 billion model. That's a standard architecture transformers can load, so I loaded it directly and pointed at my forward documents. It ran cleanly. 6.7 gigs of VRAM, about 5.4 seconds a page, and 91% keyword recall. As a recognition engine, it's genuinely strong and sits comfortably within 8 gigs. If all you want is a good OCR model that reads a page, this delivers. But here's the catch the number hides. Running the recognition model alone is not running MonkeyOCR. Its entire reason for existing is the pipeline, not any one model. When I feed a full page straight to just the recognition model, I'm asking one model to find the structure, read it, and order it all at once, which is exactly the generalist approach I already measured with Qwen. It works, but it throws away MonkeyOCR's actual innovation. The structure stage that reads each block in isolation, and the relation stage that stitches them back together. So to run the real thing, I need all three stages orchestrated together, and that's where an 8 gig Windows laptop hits a wall that has nothing to do with VRAM. The full pipeline is designed to be served with lm-deploy, a high-performance framework whose fast engine is compiled CUDA code that targets Linux. I installed it on Windows, and it pulled a heavy dependency tree before failing to come up. On top of that, the structure stage needs PaddleOCR, whose Windows GPU builds are their own ordeal. The model fits. The serving stack doesn't. Since this closes the series, here's the map I wish I'd had at the start. Across every episode, nearly every OCR model I ran. Surya 2, GOT, dots.ocr, PaddleOCR-VL, Qwen, DeepSeek, MonkeyOCR's recognizer, sat in the 4.5 to 8 gig range on this one card, most with room to spare. A 3 billion class model at full precision is right at the edge, and quantized to Q4, it's comfortably in the middle. VRAM was almost never the thing that stopped me. What actually stops you is the stack around the model, dependency and version walls. DeepSeek needs an old transformers, dots.ocr and PaddleOCR-VL want mutually exclusive versions. MonkeyOCR wants lm-deploy. Serving frameworks that assume Linux. Surya wants VLM or llama.c, PP. MonkeyOCR wants lm-deploy. And the speed quality VRAM triangle of quantization. Half my time this series went into environments, not inference. Meanwhile, the things that work turnkey on 8 gigs. A fully local RAG stack, a LoRa fine-tune, GGUF quantization, were the best findings of the whole run. So the honest shape of local-OCR in 2026. The models are ready for your laptop, but the ecosystems are still catching up. MonkeyOCR crystallizes it perfectly. Its recognition model fits and reads well on 8 gigs, so the model was never the problem, but its turnkey pipeline is built for a Linux server, not a Windows laptop. You can have MonkeyOCR's reading power on 8 gigs. You just wire it up yourself. Thanks for following the whole series. Now go run something on your own machine. You have more headroom than you think.